All right, so now we want to take a look at some numerical summaries for random variables, okay? And to begin with, there are four numerical summaries in statistics, which include the measures of central tendency, also known as averages. We have measures of dispersion, we have measures of position, and measures of shape. But in this tutorial, we will just focus on the measures of central tendency, measures of dispersion, and measures of shape, okay? Now with measures of shape, we are going to use moment and moment generating functions to derive it, okay? So let's begin with measures of central tendency, okay? When we talk of measures of central tendency, also known as averages, we have different aspects of it, which include the arithmetic mean, we have the median, we have the mode, we have the harmonic mean, we have weighted mean, etc. But in this tutorial, we'll just focus on the arithmetic mean, also known as the expected value of the random variable, okay? So the mean of a random variable often gives us the long run average value of the random variable. And that is to say, if a random variable is associated with an experiment and the experiment is repeated many times, then the average of the many observed values for the random variable will be approximately equal to the expected value, okay? All right. So mathematically, the expected value or mean of a random variable x is given by the expression below. So if our random variable is create with this expression here, and if the random variable x is continuous, we'll use this expression, okay? So now let's take a look at this framework. The expected value of a random variable has the following properties, okay? So one is that if c is a constant, then the expected value of the constant will still be constant, okay? Also, if x is a random variable and c is a constant, then the expected value of the this expression, that is the product of the constant and the random variable, can be expressed in this form. Just have to pull the constant out so that you can take the expectation of the random variable x, okay? And finally, if a and b are constants, then for a random variable x, the expectation of ax plus b is equal to a expectation of x plus b, okay? You know, once you take the expectation of a constant, is still constant, okay? So I think this is quite good. All right. So now let's take a look at an example. X is a discrete random variable with probability mass function, okay? And we want to find the expectation of X. So let's take a look at the solution. So we know that the expectation of X, we are going to sum the product of the random variable together with its probability mass function, okay? This is what I mean. We are going to take the product of the random variable together with its probability mass function and add it to the nearest random variable, the product of this and that, and add it to the product of this and that, okay? So that's basically what we're going to do. So once we do that, we obtain this, and once you use your calculator to compute this, we get 5, okay? So this is going to be the solution for expectation of the random variable x. Now let y, another example, let y denote a random variable with probability density function. I want to find the expectation of this expression here, 2y plus 4, okay? Now, our random variable is continuous, okay? So how do we do this? So we know the expression of this can be written in this form, okay? Based on the third condition in the Mark 1, okay? We can express this in this form, okay? All right, so we know the expectation of y, because this is continuous, we're going to take the integral of the product of the random variable together with the probability density function, okay? So once we do that, we obtain this, and once we multiply, we can have this. If we take the integral, right, we're going to obtain this, and once you input the values, you obtain this, okay? So finally, you have 3 out of 4. So therefore, the expectation of this expression here can be in this form, where the expectation of y is 3 out of 4, okay? So we have it here. So this multiplying that plus 4, you obtain 5.5, okay? So very quite simple. There's going to be a try question. I'm going to leave the solution in the description of this video so you can check it out. Please, if you find value in today's tutorial, don't forget to subscribe if you have not. And thank you for watching.